In this video, we're going to take a look at improper integrals. And in this first integral, I have the integral from 4 to infinity of 1 over x ln of x cubed dx. So the first thing we want to do is rewrite this with our limit. So we have the limit as t approaches infinity times the integral of the integral 4 to t, and then 1 over x ln of x cubed dx. And now we're going to do our u substitution. So u is equal to ln of x, du is equal to 1 over x dx. So now we can do our substitution. So we have the limit as t goes to infinity of the integral from, now when we put 4 in for x, we get ln of 4. And when we put t in for x, we get ln of t. And then when we do our substitution, 1 over x dx all becomes du. So what I'm left with is 1 over u cubed. And I'm going to write that as u to the negative 3 du. And now we can integrate. So we have the limit as t approaches infinity of u to the negative 2 divided by negative 2, evaluated from ln of 4 to ln of t. And now we want to evaluate. So we're going to have the limit as t approaches infinity of negative 1 divided by 2 times ln of t squared. And I put my u to the negative 2 term, I put that in the denominator as positive because it's a little bit easier to take the limit, minus negative 1 divided by 2 times ln of 4 squared. And now we need to take our limit. So we have the limit as t approaches infinity of negative 1 divided by 2 times ln of t squared. And when we put infinity in, we're going to go to infinity. And as the denominator gets large, our overall number is getting smaller. So we have 0 here for this first term. And then we have minus a negative 1 divided by 2 times ln of 4 squared. And remember, this is all a constant. So our limit is the number itself. And we have two negatives. So here, since neither of our expressions when we took the limit went to infinity or negative infinity, we are convergent. And since we're convergent, we want to state where we're converging to. And we're converging towards the limit, which was 1 over 2 times ln of 4 squared. In this next example, I have the integral from 0 to 8 of 1 divided by the cube root of 8 minus x. And remember that this function would be undefined at 8. So that's where we're going to put our t. So we have the limit as t approaches 8 of the integral from 0 to t of 1 divided by, and I'm going to write this as 8 minus x to the 1/3 dx. And now we're going to use our u substitution. So u is equal to 8 minus x. Du is equal to negative dx. And then I'm going to say negative du is equal to dx. So now I can rewrite. So I have the limit as t approaches 8 of the integral. And when we put 0 in for x, we get 8. So from 8 to 8 minus t of, now we have 1 over u to the 1/3. So we're going to have u to the negative 1/3. And now we have negative du. So du, and then I'm going to put my negative out front. So now we have the limit as t approaches 8 times negative and we have u to the 2/3 divided by 2/3, which would be the same as multiplying by 3/2, evaluated from 8 to 8 minus t. And now we want to evaluate our integration, so we're going to have the limit as t approaches 8. And now I'm going to have negative 3/2 times 8 minus t to the 2/3 minus 8 to the 2/3. And now we can evaluate the limit. So we have the limit as t goes to 8, and when we evaluate 8 minus t to the 2/3, we get 0. So we have negative 3/2 times 0. And when we evaluate the limit as t goes to 8 of negative 8 to the 2/3, we get minus 4. So here we don't have any infinity or negative infinity terms. We're convergent. And we're converging on negative 3/2 times negative 4, which is 6. And that's all for this video on improper integrals.